Hi, this is Travis, and today we're going to test a room to see how well it contains contaminants. Okay, this is the door to our conference room. We're going to go ahead and go inside here. Pretty normal conference room, nothing spectacular about the room, nothing really spectacular about the door. So let me show you around the test setup. First off, you'll see down here, this is our contaminator. This is 2 sticks of incense that are sticking out of this thing that we're going to light. Then this is our particle meter that we have in the middle of the room. Right now it's reading PM 2.5 at about 7 micrograms per cubic meter. And then as we walk over to the other side of the room, this is the door to the room. And just inside of the door, I've set up another particle meter. So we have a particle meter here. It's reading 5 micrograms a cubic meter at PM 2.5. And then as we step outside of the door, you'll see that we have this, this is our great stand here, a trash can. We have another particle meter. This thing's also reading 5 micrograms a cubic meter at PM 2.5. These are just standard incense sticks that you buy at the head shop near your house. And once they're going, they put out a pretty consistent stream of smoke. I'm going to log down the actual start time of the test here. And what you'll notice is that it starts to move that meter pretty much right away. So I'm back outside the room. The first phase of the test doesn't require me to do anything in there. I just lit the incense sticks, and we're going to let those meters read for about 15 minutes, and we'll let this meter outside the room read for about 15 minutes, and we'll see what happens. Okay, it's been 15 minutes. My PM 2.5 meter outside the room here is reading.
Up next,
7.
traffic for 5 minutes.
And my
3,
phone just told me that
2, 1, traffic.
My phone just told me it's time to walk into the room. So we're going to open the door, walk in the room. It's nice and smoky in here. Close the door, wait for about 20 seconds, and then walk back out. I'm watching my clock here. So I'm going to stop the video. I'm going to walk back out of the room. I'm going to do this 3 more times. 3 more times? Maybe 2 more times. No, 3 more times. Walk in the door, pause for 20 seconds, and walk back out of the door. Actually about 3 more seconds, I'll walk back out. All right, that's it. Walk in, walk out. I'm on my second tour inside the room, but just to show you what's going on in here, my indoor PM 2.5 here is at like 409, 410. So we have a healthy amount. And here's my incense sticks. I don't know if you can see those kind of burning. Nice. Last trip into the room. Okay, so we've reached the end of the test period. I'm going to walk into the room one last time. Sorry, I have to hold this cup of water here. So I'm walking into the room, close the door behind me, and then we're going to put out our contaminant source, right? Come on, buddy. Okay. So now our contaminant source is out. I'm going to leave the room, and then we're just going to let the room sit here for really the next hour, 45 minutes. The period of watching the PM 2.5 fall off will tell us how much ventilation there is in the room right now. There's a supply diffuser above me. You can't see it. There it is. But it is working. There's air in this room, and so we'll see how effective that ventilation is. Okay, so the next thing we're going to want to do is bring that data into Excel so that we can play with it and evaluate how effective that door is at containing contaminants. So this is what that room looks like. And we're just going to do this based on the PM 2.5 data. So there's PM 2.5 data for the center of the room. We have PM 2.5 data for, in the inside door, PM 2.5 data outside the door. And this is a big string of data. So you see the data moving during the test. So we can chart that data. If we chart it all, it looks like this. But I wrote down the time periods of the test, and so we can actually crop this data down to two different things that we want to look at. The first thing we want to look at is the containment period itself. Let's back off the zoom a little bit on this, and you can see what happened. This is the containment period itself. This is when we started contaminating the room, and then just throughout the contamination period of the room. And you can see that that's the 15 minutes that we ran with the door closed. And then here's the door opening events. They actually show up pretty well, right? Door opening events, you can see them. But throughout that period, what we actually want to look at is units of dose, which is micrograms per cubic meter times time. And since this is 1 minute interval data, we can literally just sort of sum up, the minutes in micrograms for each observation there. So if you were standing in the middle of the room, you would have received 10,800 microgram per cubic meter minutes as your dose. But if you were standing outside the room, you would have received 332. And so the containment ratio or contamination ratio of outside the door to the center of the room is 0.03. The containment ratio from just inside the door to just outside the door is 0.05, which is to say that the barrier effectiveness or barrier efficiency of that door from the center of the room to outside the room is 97%, but from just inside the door to outside the door is 95%, including the door opening events. The next thing that we look at is that decay period. And so this is what happens to the room once we stopped contaminating and just let it fall off. And so we generally look at this so that we can see how much ventilation is in the room. This curve fits. So you can curve fit it directly to the air changes per hour equation. And in the center of the room, we're seeing an effective air change rate of 3.2 air changes. And then inside the door, we're seeing an effective ventilation rate of 3.4 air changes per hour. So that's kind of the shape of this curve. You could actually curve fit it if you want. Usually, it's data, so it doesn't come in great, but you can put a trend line to it if you want to see kind of what those trends might actually look like. So anyway, that's what the data looks like. We look at this decay data to characterize the room, how the room actually performs itself, and then we look at this containment period to characterize that barrier effectiveness.